Hi friends, today we will discuss about the characteristics of DC generators. So mainly there are characteristics written here. So first one is open circuit characteristics or magnetization characteristics, load characteristics, internal characteristics, external characteristics. Okay, and another fifth one is also there, armature characteristics, but that is not that much important. So let us see these four characteristics now. Okay, open circuit characteristics are drawn between EG versus IF. Okay, generated voltage versus field current at at speed constant. It is constant speed. And load characteristics are drawn between VT versus IF at IA and N. Both are constant. IA is equal to constant and N also constant. And internal characteristics are drawn between EG versus IA, okay, at speed constant. And external characteristics are drawn between VT versus IL at speed constant, okay. VT versus IL, this is internal characteristics, external characteristics. So now let us see all these characteristics for each type of generator. So first one, separately excited DC generator. So for this you have to draw the circuit diagram first. So for the separately excited generator, field is given a separate excitation, so through one resistance to change the field current, okay. So here DC supply is given, and we have to keep one ammeter here to know field current, and this is armature current. So keep one armature, one ammeter and one voltmeter across this, okay, to know the voltage, and keep one switch, okay, and it is the load. So this is VT, right, and generated voltage is easy, the armature resistance is RA. Okay, so this is the circuit diagram. So first of all, open circuit characteristics or magnetization characteristics. So we have already seen these characteristics in the last video, that is OCC of a generator. Okay, so that means open circuit means you have to open this switch, yes, and you have to vary this field rheostat, and flux will be varied, so that you have to draw the you have to take the readings of this voltage in this ammeter, okay, at constant speed, obviously. So we have already seen that characteristics are like this. So this is EG and this is IF. So the characteristics will be like this. Is it clear? We have already seen this, right? So this is due to a residual magnetism. So this is the residual voltage, and it is linear up to some point, that is knee point. After this it will bend due to saturation, okay. So this is the OCC curve. So next, load characteristics, okay. Load characteristics means VT versus IF. So now you have to close the switch, yes, and you should make sure that throughout the experiment the armature current IA is constant, and you have to note down the values of V and IF by changing the field current. So that will be, you have to note down some readings, and that will be like this. So if it is OCC is moving like this, this is a load characteristics, okay, load characteristics, okay. So for a particular field current, okay, so this is the voltage generated at no load, and this is the voltage generated at load. That means it has decreased. Why it has decreased? Because of two things, okay. First one is armature reaction, second one is armature reaction, and second one is IA-RA drop. So because of these two things, the voltage will be decreased at load. So initially there is no load while drawing OCC. So if there is no load, there is no armature current. If there is no armature current, there is no armature reaction. Okay, and if there is no armature current, there is no armature resistance drop also. But while considering load, that means if you connect the switch here, okay, armature current flows, so there will be IARA drop, and similarly armature reaction drop also. Because of armature reaction, there is a demagnetizing effect. Because of demagnetizing effect, the voltage will be dropped, right? So this total drop is due to two things. One is armature reaction drop, another one is IARA drop. So so from this is a VT curve. Okay, so for this VT curve, if you add IARA, then that will be like this. Okay, so let this point be A, and this is B, and this is C. Okay, so this AB is due to is the drop due to IARA. Understand? This is due to IARA. So remaining this BC is due to armature reaction. Understand? So this is a VT versus IF curve. This is load characteristics. So for this, if we add IARA drop, this will be like this. So this AB is dropped due to IARA, and BC is dropped due to armature reaction. This total is drop. AC is the total drop due to these two things. Okay, so this is OCC and this is load characteristics. Now come to the internal and external characteristics. So internal characteristics, so EG versus IA at a constant N. So when speed is constant, okay, so field is also constant. Okay, you are not changing the field also. So flux is constant. So obviously, so this is the EG. Okay, so this is IA. So IA is 0. IA is 0 means no load. At no load, the voltage is easy. But at load, okay, there will be reduction, okay, due to these two things. Similarly, okay. So the curve will be like this. Understand? The curve will be like this. So again, so at rated current, I rated IA. So this is the drop due to armature reaction, and this is the drop due to IARA drop. Understand? So initially at zero current, that means no load, so the voltage is easy. Okay, so if you increase the IA, so armature reaction will be coming into picture, and armature drop also will come into picture. So the voltage will be decreased. So this decrease due to armature reaction drop, and this decrease due to IARA drop. So the total will be like this. So this is actually VT, right? So this is VT. That means this will be the external characteristics. Okay. So internal characteristics means only this one. This is EG versus IA. Okay. Because EG is equal to VT plus IARA, right? So this is VT. If you add IARA, that means this drop, you will get this one, right? So this is internal characteristics, and this is external characteristics. So this is the VT line. So if you add IARA drop to the VT, so you will get EG versus IA. Okay. I hope you understand. Okay. So these are the external characteristics. So next one, this is about the separately excited. Next one, shunt generator. So DC shunt generator. So for the DC shunt generator also, the only difference is, so this is connected to here, right? So here we should not give the separate DC source for the shunt generator. So these terminals are connected like this. So there will be small differences in the magnitudes of the currents, but the shapes are same. Okay, the shape of OCC is same, the shape of load characteristics also same, and these drops also same. Okay, everything is same. But coming to external characteristics, internal and external characteristics of a DC shunt generator. Okay, so internal and external characteristics of a DC shunt generator. So there will be one more quantity adding here. So so this is a constant EG. Okay, so 1 2 3. Okay, so now this becomes external characteristics. Okay, and this becomes external characteristics. So here there are 3 drops actually. So in the separately excited DC generator only there are 2 drops. One is armature reaction drop, another one is IRA drop. But here at rated current, okay, this will be IRA drop, and this will be armature reaction drop, and this will be the drop due to these two things. Okay, so actually because of armature reaction drop and IRA drop, the voltage generated will be decreased. Okay, so because of that voltage generated decreased, the field current also decreased, right? So but in separately excited, field current is constant. So you are giving the separate DC source to the field current, so there is no extra here, but here there will be another extra drop. Okay, this is the drop due to these two things. Okay, armature reaction and IRA drop. Because of these two decreases, EG decreases. If EG decreases, field current also decreases. Because of that, again EG decreases, right? So that is the thing happened in the DC shunt generator. Understand? So this will be the external characteristics, and this will be the internal characteristics. Understand? So this curve will be the internal characteristics. Okay. So this is about the DC shunt generator characteristics, and we will see the series generator and compound generator characteristics in the next video. Thank you.